superposition. So not only is this amazing, remember subatomic particles are weird, we've got the entanglement, we've also got a thing called superposition, where a subatomic particle is in many different places, many different states at the same time. It's dead and alive and all the way in between. It was proven by this, the double slit was first done in 1805 by Professor Thomas Young. He did it because to prove light was a wave. So he got a very little bit of light, went through two slits, and then there's an interference pattern. One thing you've got to remember, there's two things, an interference pattern and a clump pattern. So the light goes through the slits, and then it's captured on the captured board, and it's either an interference or a clump. If this were firing bullets, what would you expect to see through two slits? Two lines, which is a clump pattern. If it was water, and I was pushing the water through, it would interfere with itself like waves, and it would touch the screen in many places with the densest in the middle. He did it, he said, oh look, we've got an interference pattern, it's a wave. This is 1805. Everybody, light is a wave. Fantastic. In 1905, 100 years later, for that 100 years we all believed it was, light was a wave. In 1905, Einstein, by the way, I know we talk about Einstein a lot. In 1905, Einstein published 4 pivotal scientific papers. People would normally publish 1 in a lifetime. He did 4 in 1 year. 1 was the special theory of relativity. I could get in a spaceship, go near the speed of light, come home and be 100 years younger than my granddaughters in every way. You know, the blood going through my veins and everything slows down. Where was I? Oh yeah, so in 1905 Einstein did these 4. He did Brownian motion. He did something called the photoelectric effect, which proved beyond doubt that light was a bullet, it was a particle. And he said, this is strange. I'm not saying Thomas Young is wrong, but it's definitely a particle. Long story short, light and everything is a thing called wave-particle duality. It's both at the same time. It's a wave that has properties of a particle. It's a particle that has properties of a wave. And it's very, very strange. What happens is, it went through there and there was an interference. Now, this is where nature prevented us from knowing. And this is probably 1980s, we could send through 1 photon at a time. And we thought, great, we're going to find out. We're going to put a camera here, we're going to watch it go through the slit, and we're going to work out what's happening. Great. As soon as they put a camera there, can anybody guess what happened?
Affected by the observer.
Sorry?
Affected by the observer.
Yes, and it definitely, that instantly becomes a clump. Take the camera away, it's an interference. It's as black and white as that. Yeah, it's the observer effect. If you,
I think you should rename it to the fuck you effect.
Yeah. I have scratched that from the recording.
Oh, that's funny.
I do not approve. Yeah.
Do not resemble this remark. Take
I would. Look, if there was a vote for that, I'd vote yeah. What is going on again? How does a subatomic particle know when it's been watched?
It's gone.
Who thinks I'm a nutter? Yeah,
For
thank you.
other reasons.
I accept that. I accept that.
Good call.
Yeah.
I heard that it was because when you observe something, like we know that observation is light.
Oh, can we have another clap again? Hold on, you're not right. But
Points
You have just said what the scientists said. So they said, don't forget, it's all about knowing which slit it went through. It's called the which way, which remember we can't know for an atom. We can't know its location, its momentum. So knowing the which way would ruin all of that. A scientist quite rightly raised, and honestly, that's a really good one.
I have to give credit to Roger Penrose.
Oh, he's one of my heroes, although he's lost it a bit, I reckon. But we can discuss that. The microtubules and all that in the brain, are you aware of that? Or
Yeah, I read The Emperor's New Mind.
yeah, I have to. And he's, the microtubules where he reckons consciousness is, but we won't stop. Where was I? Yeah, so we got it there, take it away and put it back. Oh, no, I was answering your question. Great point. Because when you measure it, you actually do send a photon of light, and it hits that photon of light, so it disturbs it. Now, it wouldn't, scientists said, look, it doesn't explain why it goes to a plug, but it is one more factor of what's happening. And then some clever guy, probably Irish, at the back of the room said, why don't we get the detector and aim it so we know which way it's going? We're not going to measure it, no light going to and from, we're just going to know which one it goes through. What happened? It clumped. How can that be? So just by not knowing, not measuring, just by possibly knowing, nature said, you are not going to work out what's going on.
So what was